Welcome to the third preparatory stage science course. I am Rania Hasabo and I am going to be your teacher here during this course. The goal of this work is not only for the exam, but also for understanding and linking information to the life around you. Wish you all the best of luck. Now let's start. Properties of image formed by the lens. If you look at the sea through the lens, it appears upside down. Why is that? Lenses they are thicker at the middle and thin at the tips is called convex lens from the previous. This lens converges the parallel rays in a single point, which is called the focal point. Collect all parallel rays in one point, which is called focal point. The parallel rays which passes through the lens didn't travel in a straight line, but they bent slightly inward. This phenomena is called light refraction. Yes, when the light rays passes through a lens, they will refract and converge at a single point to produce an image. Because the image passes through the lens to the opposite side, it is projected upside down. To determine the position and the properties of image of the formed image by the convex lens, follow the following steps. Number one, use the compass to draw two identical intersected circles. The region of the intersection represents the focus lens. The two centers of the two circles represent the two centers of curvature. Yes, draw a straight line that join between the two centers of curvature of the lens to represent the principal axis. Draw a vertical arrow on the principal axis to represent the position of the object. Draw a ray from the highest point of the object where it falls parallel so it passes through focus. And another one passes through the optical center of the lens so it exists without any refraction. Draw an arrow whose head is at the position of the intersection of the two refracted rays, which represents the image. Determine the position and the properties of the formed image. Repeat the steps several times by changing the position of the object each time. Number one, very far object. Draw the lens and the principal axis and determine the two focuses and the two centers of curvature and the optical center of the lens. If sun rays fall on the lens, we notice that all sun rays are parallel to each other and fall on the mirror parallel to the principal axis. So, it converged and collect in a real focus of the lens. So the image of sun is a real tiny dot at focus. Number two, at distance greater than the double focal length after the center of curvature. Okay, we draw ray from the highest point of the object. Number one falls parallel, refracts, passes through focus, and second one passes by optical center of curvature, which passes without any refraction. So the image formed between center and focus, real, inverted, and minimized. Yes, real, inverted, and minimized. Number three, at distance equal to the radius of curvature at the center. Draw the lens and determine the points, two foci and the two centers of curvature. Draw the first ray parallel, refracts focus, and second one passes by optical center, passes without any refraction. So the image formed at center of curvature, real, inverted, and equal to the object. The properties of image, real, inverted, and equal to the object. Number four, at distance greater than focal length but less than radius of the curvature, means between center and focus. Parallel, refracts focus, and second one passes without any refraction. So the image which formed real, inverted, and magnified larger than the object after the center of curvature at distance more than the radius. Yes, real, inverted, and larger than the object, magnified. If the object stands at focus, repeat the steps by drawing the lens and the principal axis. Determine the points. The first ray parallel, refracts passes by focus, and second one passes without any refraction. So The two refracted rays are parallel to each other, so no image is formed. Yes, there is no intersection, no image is formed. If the object stands at distance less than focal length before focus. Repeat the steps. The first ray, parallel, refracts, passes by focus, and second one passes without any refraction. We notice that the two refracted rays are diverging rays, so the image is formed as a result of intersection of the extension of the refracted rays. So the image is formed farther than the object position and in its same direction. Virtual, erect, and magnified. Remember with me the properties of image. If the object is very far as sun, it will form real tiny dot at focus. While if it stands at distance greater than double focal length, it will form a real inverted dimensioned image between F and C. While if the object stands at C, at center, it will form a real inverted equal-sized object at the center. At distance greater than F and less than radius between C and F, it will form a real inverted magnified image after C. At focus, no image is formed. While if the object stands at distance less than focal length before F, it will form a virtual erect magnified image at the same side of the object, farther than the object. Activity 1. To determine the focus and the focal length of the convex lens. Material: convex lens, light source, and screen. Fix the lens where the light source is facing one of its faces. Move the screen closer and farther from the other side of the lens until you get the lit point. Measure the distance between the lit point and the optical center. We observe that parallel rays fall on the lens, and the rays after being refracted are collected in one point, which is called focus or principal focus. The conclusion: the convex lens is converging lens. Number 2, the point of collection of the parallel rays after being refracted from the convex lens is called focus. Number 3, the distance between focus and the optical center is called the focal length. Focal length equal half radius. What happens when a beam of light rays parallel to principal axis fall on the concave lens? The parallel rays passing through the concave lens, then they are diverged, scattered from each other, diverged, and their extension are collected in a virtual focus. So we have two focuses. The first one, in case of convex lens, it is the real focus, the point of collection of refracted light rays, while in concave lens it is the point of collection of extension of the refracted light rays. Concave lens. It is a transparent optical piece which is thin at its center and more thickness at the tips. Concave lens is called diverging lens as it separates light rays falling on it. The parallel rays passing through the concave lens, then they are diverged and their extension are collected in a virtual focus. Yes, it has a virtual focus. It is the point of collection of extension of refracted light rays. Principal focus, in case of concave lens, is virtual. Draw concave lens and the principal axis and determine the points. The first ray from the highest point of object passes without any refraction as it passes by optical center, but the second one is parallel. It is refracted, diverged, and its extension are collected at the virtual focus. So the image which formed is virtual, erect, and dimensioned, formed from the intersection of the extension of refracted light rays. Wherever the position of the object in front of the concave mirror, the image is formed near to the object position and in its same side. virtual, erect, and dimension. Yes, the properties of image formed by the concave lens not affected by the position of the object. Always virtual, erect dimension and near to the object position in its same side. Camera is made up of large number of lenses, each one responsible for such role as adjust color and focus as well as changing the focal distance. Yes, of course, the technology helps us to capture beautiful images. Now, I will leave you with my most important and
Hello
lovely
guys,
student
today
to
we'll learn
explain
together how to
draw
draw a
lenses.
concave lens. We'll use a pencil, a protractor, and a compass. Firstly, draw a straight line which represents the principal axis, which is a straight line that joins between two centers of curvature of the lens. Now bring a compass. Let the sharp, thin one on the 0 and the other one, which is a pencil, on 3.5. Okay, obvious enough. Now we will draw a half sphere, which is only one face from a sphere. This way, keep it clear for sure. If you will leave 4 lines up, so leave them the same down. 4 lines up, 4 lines down. Then go to the other center. Now draw the other face of the other sphere. This way. Now we'll close it. We'll use the pencil and the protractor. You can use a normal ruler if you want. I left 3 lines up and I will leave 3 lines down. Voila! Now we will keep the distance between the optical center and the face of each sphere equal. For example, if it's half here, so it should be half here. And I will draw a line segment passing through the optical center in order to divide the concave lens into 2 parts. And for sure we will delete the extras together, because we don't need them at all. Voila! Hope you liked it. We will draw a convex lens using a pencil, a protractor, and a compass. We'll bring the protractor, then put it here in order to draw a line segment joining between 2 centers of curvatures of the 2 faces, which represents the principal axis. For example, from 4 to 4 in order to make the distances equal. That's it. So surely the 0 will represent the optical center, and under the number 2 I'll write the first focus, and the other 2 will be the second focus, because in the lens we have 2 centers of curvatures and 2 foci. Here will be center 1, and next to it I will write focus 1, and here will exist focus 2 and center 2. Now we will use the compass in order to draw 2 identical intersected circles. But firstly, let me put the sharp thin one on the 0 and the other one, which is the pencil, on 4.5. Go to one center and draw a face of a sphere, and then draw the other face of the other sphere from the other center this way. And for sure we will delete the extras because we don't need them, as well as they have a silly look and shape.